Question 11. Find the internal force BD. Okay. So pause the video and decide what to do. And when you're ready, press play. So in this case, we want to find the internal force BD. We want to cut through our framework in some way of cutting through BD. So we could cut it through at this point here, or we could cut it at this point here, slightly further down. Now the best solution, I think, to solve this problem is actually to cut it through this point here to try and find BD. Why was that slightly better? Well, notice that by cutting it through here, what do we end up with? We have two unknowns coming from this joint here. So that means that since I'm looking for only BD, that these two unknowns are both coming from C. And what do I want to do to solve the equations just have BD? I want to take moments at C. Okay, so you've got a slight choice there. You could also cut it through here and start examining the problem. But the problem is then we'll have this unknown BC coming off in this direction, and we would have this force here. So a bit more difficult then to isolate BD, and I actually have to do two calculations, I think, to get to it. So I don't actually need any angles. It's another advantage of this. So we're going to take moments about C. So that's going to give me a distance of 4 meters away from BD. What have I got then? So 4 meters away. Here the 120. So I measure that and notice that that's going to be 4 meters away. So I just measure that, bring it down to here. And then the other force I've got is this 100 and it's going upwards. So that's going to create a turning moment, and that's going to be 8 meters away. So we have BD times by 4, take away 120 times by 4, plus 100 times by 8. So I'll rearrange them. So we've got 480, take away 800, and we want to divide that by 4. Just trying to do that in my head. So we got 3 minus 320. Is that right, isn't it? Yeah, minus 320 divided by 4, so that's minus 120 minus 80. Is the final answer.